Okay, so the skill for this week is going to be being able to trace through a program that has subprograms and to show what is happening with all of these activations on the stack. And so I'm going to work through a short example here to show you how to work through these. Here is a program over here on the left, and you can see that it has nested subprograms. And then below that is the layout that we're going to use for our activation records. So we're going to run this in both static and dynamic, and the stack is going to look the same in both of them, but the output is going to be different. So here we'll do the output for static, and then here we'll do the output for dynamic. Okay, so let's start this. So everything is inside of P, so we can assume that P stands for program or it's some sort of main. So that's going to be the first activation record on our stack. You can draw your stacks growing downwards or upwards in this course. It doesn't really matter. But what you should do is you should indicate to me which direction the stack is growing using something like an arrow like this. So let's start with P's activation record. So here is P's activation record on the stack. It only has one thing, which is a local variable. That local variable is called x, and it is equal to the character P. So that is the stack frame for P. The only thing that P does is it calls B. So I'm going to now draw a stack frame for B. B is going to have if we look down here at the things that that could be in a stack record. So we have local variables. We're going to have one of those. B has a local variable. We're going to have a static link and a dynamic link. At this point, both of those are going to point back to P. And then we're going to have a return address, which is the address to go back to in P. So notice that we didn't have any of the three of these things in P's stack record. Okay, so since we're going to have four things, I'm going to leave a little bit more space for B than I did for P. So here is B. So we are going to have a local variable. It is also going to be x, and its value is going to be B. We're going to have a static link, we're going to have a dynamic link, and then we're going to have a return address. So the return address here is just the place where we're going back to in the program. And since I've given you line numbers, then we'll just refer to these as line numbers. So we're going to go back to line 22, which is, if you look over here, this is where, oh, you can't really see that. So line 22 is where we called B. So that's where we're going to go back to. Now, a little caveat here for those of you who are remembering function returns from 261, you may remember that when we run the call instruction, we push the address of the next instruction onto the stack. And that is correct. That is what you would want to do under the hood. However, since we're working at the source code level here, there may still be other things on that line that we need to do after the function returns. So for the purposes of this class, I want you to write the return address as being the address where the call or the line of code where the function call is happening, not the next line. So this is going to be 22 and not 23. Okay, we need to figure out what the static and the dynamic links are. Well, here the static link is going to be to P because B is contained inside B. Here is contained inside of P, and so we can draw that like this. So this is the, I guess let's switch back to black. So this is the static link, and it is going back to P. And then we have the dynamic link, which in this case, whoops, is also pointing back to P because P is what called B. Okay, so that is the activation record for B. Then the only thing that B does is it calls C. Again, C is going to have all four of these things. It's going to have local variables. It's going to have a static and dynamic link and return address. So I'm going to leave enough room for all of those things here. So this is the stack record for C. So it has a local variable called x. Its value is C, as you might expect. We're going to have a static link, a dynamic link, just like we had for B, and we're also going to have a return address. So again, that return address is where C was called, which is line 20. So now we need to figure out the static link and the dynamic link. So for the static link, we look at where C is contained. So C is contained inside of B. So the static link for C needs to point to B. The dynamic link is also going to point to B because B is what called C. So in this case, the dynamic link again is pointing to the same place as the, pointing to the same activation record as the static link. Okay, so now we're going to see something where they're different. So here D calls A, C calls D. And so you can see that the dynamic link is going to point back to C, but because D is contained in B, the static link for D is going to point back to B. So here is another stack record for D. Note that D doesn't have any local variables, so we don't need that portion. So for D, we're just going to have a static link, a dynamic link, and then a return address. So D was called on line 14, so that's where we'll go back to. Like we said, D is contained inside of B lexically, so its static link is also going to point to the beginning of B. So this is the kind of trail that we have going back to the beginning of B. But then the dynamic link, so the link back to the stack frame of this subprogram that called D, that's going to point to the stack record for C. Okay, so then inside of D, and I realize I'm kind of skipping over the print line at this point. Actually, I probably shouldn't do that. I should go ahead and do the output at this point. So the output, so there was no output in B, so there was some output in C, and I probably should not have skipped that. So inside of C, when we did the print line, only P, B, and C were on the stack. And so when we printed X, there was an X defined inside of C, so we didn't need to use the static or the dynamic links at that point. So the output for both the first output for both of these schemes is just going to be C, because inside of that function we're going to see the local variable. So that's not a terribly interesting output yet. Okay, but then once we call D, we're going to print X again. And here we are going to get a difference because D does not have a local variable called X. And so we're going to need to search using the static and the dynamic links. So in static scoping, we're going to search using the static links, and D's static link points all the way back to B. So here's the static link for D, and I follow it all the way back to B, and I can see that B has a local variable called X. So that is going to be the output for the static version of this. And note that if we hadn't found it at that point, we would just look at B's static point or static link and follow that back to P. Under dynamic scoping, here inside of D, we would look at D's dynamic link, which points us back up to C. And so here is the difference, because whereas in static scoping we found B's version of X, in dynamic scoping we're still going to use C's version of X. Okay, So now the last thing that happens is, or the last subprogram that's invoked is A. So D calls A. So we're going to have our last activation record on the stack here. And so that is the activation record for A. It is going to, there are again no local variables, so there's only going to be a static link, a dynamic link, and a return address. And the return address for A is going to be the line where it was called, which is 18. The static link, so the enclosing scope for A, so A is defined inside of P directly. So it's not nested inside any of these other subprograms. So the static link for A is going to be P. So we're going to need to draw this, and I think I'll try to make it go up through here because we want it to join back in with that line there. So, drawing these things is a little bit of an art form, but as you do more of them, you'll get a little bit better about seeing how to line things up. So we want the static link to point all the way back up here to P, and then we want the dynamic link. So when setting this up, we need to think about who called A. Well, D called A, and so the dynamic link for A is just going to point to D. I recommend when drawing these things to sort of assign a vertical line for each activation record, and that'll make it easier to connect up all of the pointers and keep it all legible when you draw it. All right, so that means that when we get to this last print in A that is also printing X, we will now, under static scoping, we'll go all the way back up to P's copy of X, which means that we're going to output P here. And then for dynamic scoping, we're going to follow the dynamic links, and that will get us back up to D. D does not have a local variable called X, so we need to follow the dynamic link again, which gets us back up to C, which means that yet again, we're printing out C's copy of X under dynamic scoping. All right, and I believe that concludes this example. So as the functions return, these records would go off the stack, but typically I'm going to be asking you to draw these things sort of in their deepest form, where there are the most things on the stack. And so I think that we will stop the drawing there and just realize that as these functions return, each of these things would be popped off the stack, or the stack pointer would be adjusted such that they're no longer on the stack. As you learn in 261, unless you overwrite the memory, the contents is still there, but if the stack pointer has been moved such that it's no longer on the stack, then accessing that memory would be considered invalid. All right, and that concludes this example.